real practical transformer, it was different from the maybe ideal transformer. Okay? So this figure is for practical transformer. This is the primary side. Oops, here. This is the primary side. This is the secondary side. Okay. Uh, L sub P is the primary leakage inductance, and the I sub P is primary the Cooper losses. So for the future lecture, we're gonna talking about more in detail, explain about the Cooper losses and core losses. But from here, I wanted to show you what is for the real transformer, the compounds, okay? And then in the pedal, the RC is core losses right there. The core losses due to the eddy currents and hysteresis, and L sub M is the magnetizance, the inductance, okay? And then also in the secondary part for the resistor is R sub S is secondary Cooper losses, and L sub S is the leakage, the secondary leakage, the inductance. Okay, so we're gonna choose primary and secondary side to make a one circuit from the isolated two primary secondary of transformer. We remove to the R sub C, yeah, R sub C and X sub C. Maybe L sub M. Okay. So I mean, we will not consider about the core losses and the magnetizations, the inductance. Okay. So that is the circuit. So from this, the previous one, we have to let's go side here. We can make it equivalent circuit. We can make the equivalent circuit of rear transform refer to primary side. Okay, so that is, we can make it redrawing. So this is R, this is L, this is I1. Okay. So this is R sub I1, and that was euro, okay, right there. Okay, so that was is equivalent register refer to primary side. So is equivalent reactance refer to the primary side. So here, R sub I sub E1, the primary side still keep here. So R sub 1 plus the R sub 2. The secondary part maybe of the register, that was N sub 1 over N sub 2 squared. Okay. So that was to make it for the primary side of the register, equivalent register. And then X sub 1E, same thing. X1 in the primary side reactance still keep there. And secondary part, we're gonna N sub 1 over N sub 2 squared. Okay. So that was the each different to equivalent register and reactance referred to the primary side. Okay. So how about the secondary part? Equivalent circuit of real transformer referred to secondary side. Okay. So here, that was for E2, E2, oops. Yeah. And still just of L right there. Definitely that was in sub 2. Okay, so that was R sub E sub 2. The same thing, R sub 2 plus R sub 1. That was reverse, okay? That was the reverse, N sub 2 over N sub 1. Okay? That's very important. Reverse is different here, okay? And then X sub E sub 2, X sub 2 plus X sub 1, N sub 2 over N sub 1 as well, okay? Now we have sample questions we learned before. So in the class, okay, right there. All right, so this is the questions, okay? So equivalent resistor and reactance of 50 kVA and 2400 V and 480 voltage transformers winding are R is 2.8 ohm and X of a reactance, definitely the high voltage side, means like primary side there. High voltage is the primary side, and the road is what? 10-20 degree, okay, on here, connect to the low voltage side. Okay, so the determined here. First over, we have to draw equivalent circuit refer to the high voltage side. So that was the high voltage side, mean the primary. And here, it's overall prime. Okay, that was 2,400. Result 1 R 2.8 ohm, X of L 6 ohm. That was n sub 1 over n sub 2 squared in between them. Okay. So, that was for, so just a rod, maybe n sub 1 volt, 480 volt square, 10, 20, the ohm here. So because n sub 1 over n sub 2, v sub 1 over v sub 2. Okay, that is what we learned before. So here, that was 5 squared, 10 times 20. So 250 and 20. Okay, that's the answer. Okay. Question B. What is primary current if the rate voltage is applied to the primary side? So from here, how can we find the primary side, the current? That was like this one, the I sub P. Right to here, the I sub P, 2,400 volt, divided, what? 2.8 plus J 6 ohm, goes reactance of the inductor, and plus 220 over here. Okay, I'm gonna skip the calculations. So finally, you're gonna 254.7, 21.5 degree, 2,400. So that was for 9.4 minus 21.1 degree, and so that is the answer. Okay. Let's see is what is the road voltage? And what is the road voltage? To go back to here, the question is, what is the road voltage? The road voltage in here, let's say V sub L, V sub 1 minus I sub P times 2.18 plus a J 6. Okay. All right. So right there, go back to here is so 1 minus I sub P 2.8 plus J 6. That was based on 2,400 minus 9.4 1 J 6. I'm going to skip the calculations, okay? But that was finally 2,355 minus 1.05. Okay. That is the answer. That's it. Okay.